All right, so we are going to study today about the change of states. Okay, so we have already done the properties of different states, right? Solid, liquid, gases. We have done them yesterday. Now we will see how can we convert one state to the other? How can we change them? And what are the factors which affect when we change one state of any matter to another state? Okay, we will see that. All the factors which are responsible for changing one state to the other. And we will also see what is this kinetic theory of matter is about. How does is it responsible only for the particles which are being changed in one from one state to the other? Okay, by heating or cooling, yes, but by heating or cooling is the method by which we can change one state to the other. But what are the factors? Okay, we will see that in this module. All right, so we are going to see changes of state, solid, liquid gases, ice, water, vapors, right? Ice, water, and steam. And this is when we convert them, like gas can be changed to liquid and liquid then changed to the solid. We are going to see what is exactly happening inside the particles. How are their bondings reacting when we are changing one state to the other state? Okay. There are some particular terms. What happens to the particles of matter? How does this change of state takes place? All these questions we will answer today. So, change of state. The phase or state of matter can change when
Good
the
evening, ma'am.
temperature changes. Good evening, Lavanya.
Ma'am, sorry for late. Today my network is not good.
Okay, okay. No issues, Lavanya. Okay. So change of state happens when temperature changes. Okay. So actually there are two factors which are responsible for changing one state to the other. That are temperature and pressure. Okay. Heating and cooling are the methods. Okay. Temperature and pressure are the two factors by which can influence the change of states. Okay. Now what happens when we change the temperature? What happens to the particles which are present inside the different states of matter? Can anyone tell me? Because we have done this when we were doing diffusion. When we were doing the diffusion, we have done this when we are increasing the temperature. What happened to the particles already present in the solid state, student? Come on, try to think and give the answer. They expand, okay. They expand and start moving vigorously, right? While in the solid state, they are in the very compact position. And when we start giving temperature, force of attraction will decrease, space between them become more. And what about, okay, tell me something which is in relation to the kinetic energy. Kinetic energy will increase or decrease when we start giving temperature to the solid state.
Ma'am, increase.
Yes, yes, kinetic energy will increase, correct. Okay. Each addition of energy creates a change in state. Solid to liquid. Solid, when we provide this, E means energy. Okay, so when we provide energy to the solids, it will change into liquids. When we keep on heating or giving energy to the liquids, or you can say the temperature, it will also change into vapors or gases. So Each addition of energy creates a new state of matter. As temperature rises, matter moves to a more active state. The change in state of matter is governed by kinetic theory of matter, where the space between particles become different, right? Where, as you have mentioned, like you have answered, no, the kinetic energy will increase when we keep on giving the temperature to the solid. So space between particles keep on increasing. Force of attraction between the particles also affected because it will also change. The bondings will break down. The energy which we are providing to the solid state will be used in overcoming the force of attraction or to breaking them. And then the kinetic energy of particles will also start increasing, or energy of motion, like the particles start moving randomly more. Okay. Basically, in this all this process, you have to learn that there is a temperature and pressure which is going to affect the change of state. Okay. So we are heating an ice on a pan, which is in the solid form. Particles are very much close to each other. As temperature rises, solid will turn into liquid, and it turns into liquid and particles move away from each other. Solid to liquid and liquid to gas. As temperature increases more, it turns into steam and particles move more apart, which I have already discussed with you. Always, whenever we learn about the changes of state of matter, no, always keep an ice example in your mind. Okay, students? Ice is a very prominent example in the form of solid, and then we are going to provide heat or temperature, then it will turn into liquid. And when we are keep on providing temperature to the liquid, it will turn into gas. Okay. Now, we are going to see the temperature scale. Okay, there are some SI units and some temperature numericals in your syllabus, which we will do today. So, before this, we will start this temperature thing. Can anyone tell me how can we measure the temperature? What is the SI unit of temperature? How many scales are there which can help us to measure the temperature? If anybody knows this, please write in the chat box. Okay.
Ma'am, I think Kelvin is the SI unit of temperature.
Okay, okay. And in India, we use which sort of like thermometer has which type of temperature we see?
Ma'am,
Is the,
Celsius.
Celsius. And one more is there. Okay, Om, Dhanishri, Abhay. Yeah, Celsius, Celsius. Okay. And one more is there, right? Celsius, Kelvin, and Fahrenheit. Fahrenheit. Okay. So spelling is little bit, we will see. Okay, Abhilasha and Abhay. All right, so we are going to see all those temperature scale. We will write the differences among them and we will try to solve some numericals. Okay, so now this part is totally, like not totally different, but yes, different from the first part. Okay, Mehak. All right. Temperature. It measures, like it is a measurement of hotness and coldness of a substance. It is temperature. If you people are writing, then start writing giving the heading of temperature and start the definition. It says that it is a measure of hotness or coldness of a substance. Temperature can be measured in three scales, which you have already said: Celsius, Kelvin, and Fahrenheit. Okay, so you can see the spelling of Fahrenheit. You people can write it down, this the names of these three scales. Fahrenheit is also correct pronunciation. In order to learn the spelling, you need to have the H sound in between these spelling. Fahrenheit. Okay. All right. So Celsius was the common scale which was given by Anders Celsius. Then there was SI unit, Lord William Thomson. Kelvin has given to us. Then there is a doctor scale, which is used, still being used in the US. Okay, for some industries, the people use the mostly in the medical industry. This Fahrenheit scale is being used. It was given by Gabriel Daniel Fahrenheit. Okay, okay. Now each scale have different measurement. Okay, in each scale there is a different boiling temperature, different cooling temperature, which I will make you write down. Okay, so first we are doing about the Kelvin. So temperature at which gas is cooled to obtain zero volume. Absolute is known as absolute zero for Kelvin. Okay, this is nothing which we have already know, that there is a melting point in the Celsius which is about 0 degrees Celsius. So in the Kelvin there is a relative unit by which we can measure the temperature for Kelvin scale. This is about the Kelvin scale. There is an absolute zero there which is known as 0 Kelvin. Temperature at which gas is cooled to obtain zero volume. That is known as absolute zero Kelvin. This is a point, okay? This is a point in a Kelvin which will tell us any relative temperature we want to convert, no? So this is an absolute zero Kelvin where we will start seeing the measurement of temperature in the Kelvin scale. Okay, students? Such a volume and below are not practically possible to obtain. So we are not using that much Kelvin scale. But yes, in certain like laboratories, no, in the chemistry labs and the physical labs in the industries, we still use this Kelvin scale. Okay, because there we do certain experiments which can go below this temperature. Okay, so there we make use of this Kelvin scale, but we kind of day to day use, we don't use the Kelvin scale. Okay. Hence, all temperatures are positive. First, I will go through every temperatures, like every scales, and then we will write the notes. Okay. Kelvin to Celsius. Now, these are conversions. Before this, I want you all to write about. You are going to make a difference table. Okay. You can write Celsius, Kelvin, and Fahrenheit. Make a table. I am going to make you write some notes about the definition, uses, and the temperature. Wait, students, my pen is not working. Okay, so I'm writing something. Just let me know if you all can see it. Okay, can you see it?
Yes, ma'am.
Okay, so ma'am can see no, or can't see it. Abhi?
Have it.
Okay. This one, Abhay, you are right. 0 degrees Celsius equal to 273 Kelvin. You are correct. Okay. So we are going to write it now. So first we will write about Celsius scale, Kelvin, and then. So the first point for the Celsius scale, you are going to write it. A metric scale, a metric scale, a metric scale where water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. So this is a metric scale, everyone. Celsius is a metric scale. Now Kelvin, come to Kelvin column and then write it. It's an absolute temperature scale. An absolute temperature scale where 0 Kelvin is absolute zero. In bracket, you can write minus 273.15 degree Celsius. Water, here water freezes at 273.15 Kelvin and boils at 373.15 Kelvin. And then for the Fahrenheit scale, you are going to write down a scale where water freezes at 32 degree Fahrenheit and boils at 212 degree Fahrenheit. So there is nothing logic in this one. These are sheer some units, okay, for Celsius, Kelvin, and Fahrenheit. 1 point you can write it. One more point. Importance is also important. So in Celsius scale, you can write in day-to-day applications. You can use it. Even in the weather forecasting, it can be used. Celsius scale. You know, various meteorologists can use this scale to forecast the weather. And also in scientific research as well, because it is common scale. And then in the Fahrenheit, you can write, sorry, in the Kelvin, you can write engineering applications, like in the laboratories or physical lab, even use this Kelvin scale. And for the Fahrenheit, you can write use in US for everyday application. So they use Fahrenheit scale. Less common in scientific research. When you finish this, I will give you some formulas for conversions, okay? Tell me when you have done. Any word which you're not able to understand, let me know.
I'm done.
Done? Okay. Okay, so we will continue to do about the conversions. Done, everyone? If somebody is writing, okay, done. Okay, so first I have to erase this all. So for the conversions, anybody knows the formulas for Celsius to Kelvin, Kelvin to Celsius? Okay, let's see if those formulas are in the slides. All right. Okay, so we will write them because there are not much formulas here. Okay, so you can give the heading conversions, temperature conversions or conversions. Now you have to write Celsius to Fahrenheit. When we are going to convert the Celsius to Fahrenheit, then you have to write degree F is equals to Celsius. Okay, got it. 9 upon 5 plus 32. Then from Fahrenheit to Celsius, the formula is degree Celsius is equal to degree F times degree F minus 32 5 upon 9. And now the most important one, Celsius to Kelvin. Kelvin is equals to degree Celsius plus 273.15. And from Kelvin to Celsius, Celsius equals to degree Kelvin minus 273.15. Write them because we are going to do certain numericals out of it, okay? When done, please let me know. Degree F2. Okay. That much is not needed. Actually, Fahrenheit is not that much in your syllabus. So most of the question will come from Celsius to Kelvin and Kelvin to Celsius only. And Kelvin is not used against the Fahrenheit usually. So we don't have any. If you know ohm, just write in the chat box so everybody can know. And I'm going to give you a numerical now. Numericals. Wait. Okay. I have saved some numericals for you. Okay, so it isn't there much about degree Fahrenheit to Kelvin. But if it is there, I will search for you this one and I'll get to know in the next class. Okay, so everybody have written the formulas. Can we start with the numerical? So 9 students are there. So I want everyone to participate in the numerical question. I'm erasing the slide. Can I, everyone?
Yes, ma'am.
Okay. Okay. This conversions we used to do in the primary classes as well. Now it's become more easier because now they'll ask you about degree Celsius to Kelvin. Okay. Okay, so here is the first question. Convert the temperature 25 degrees Celsius to Kelvin scale. Don't forget to mention the unit, students. Okay, Abhi has given the answer, and anybody else want to? At least five answers must be there.
Ma'am, 298.15.
Okay, okay, Lavanya. Okay, so three answers are there. One, two, three, four. Okay, yes, answer is correct. So, one thing more. We don't call the digits which are after the decimal as 15, 14. We have to call them 1, 5. Okay? 298 is correct pronunciation. When there is a decimal come, so after the decimal digits, we will call them as 1, 5. Okay? Okay. So, is there any other question? Otherwise, I'll give. Okay. So, next question. Convert the temperature of 300 Kelvin to Celsius scale. Okay. 27.15 Celsius. Okay. Anybody else? Fozan has given the answer. Can you recheck again, Fozan? Okay, 27. Everybody is getting 27? 27.15. 27.15. Okay, okay. So, okay. But my answer is 26.85. Okay, who all are writing K? No, it's not K, it's C. Meg? Does anybody got this one as answer? 26.85 degrees Celsius. Anybody got this one as answer? Okay. Okay. So yes, this is the correct answer. Okay, so next one. Correct answer. Okay. One question I would like to give you on Fahrenheit. Okay. I'm writing it here. Hmm. So the question is convert 30 degrees Celsius to Fahrenheit, students. Try it. So we got the answer. 86. Ohm says 86 degree Fahrenheit. Let the other students. Mehak also says. So everybody is getting 86 degree Fahrenheit.
Yes, ma'am.
Okay. So 86 degree Fahrenheit is the correct answer. Okay. One more. One more. Shall I give one more? Minus 10 degrees Celsius to Kelvin. Do this one. What is the answer? Anybody got it?
And my answer is 263.50.
What is the unit?
Ma'am, Kelvin.
Okay. So Abhay says 263 Kelvin. Fauzan says 50 Kelvin. Mehak says 14 degrees Celsius. How come? So many different answers. Anyone who is a tiebreaker, whose answer will match to anybody, will be the correct answer. So Lavanya and Abhay till now got the closest answer. Let us see. Meg, do you want to change your answer? Okay. Okay, Abhay. So Mehak, do you want to change the answer?
Excuse me, ma'am.
Yes.
Ma'am, in my book, the
Hmm.
formula for changing Celsius to Kelvin is Kelvin is equal to degree Celsius plus 273.
Hmm. So they have taken the round off value. You can take that value as well. Round off means they have cut down the decimal one. So you can take that value as well. No issues.
Okay,
Okay.
ma'am.
To make the formula easy, they have done. Yes. So Abhay is correct. 263.15. Okay. Mehak, you are calculating. Or Lavanya also got the same answer, I think. 283? 283, no, Mehak. It is 263.15. You can check once more. Yes. Okay, everyone. So I think this conversion is clear to you. This is nothing but you just need to remember the formulas and you can do the calculations. Okay. So we are going further. Yes, minus 10 is given. Minus 10 is given, Mehak. Mhm. Okay, wait. So the question was minus 10 degrees Celsius to Kelvin. So here we will do what? K equals to degrees Celsius plus 273.15. Everybody has used this formula. Then we have
Yes,
written equal. Yeah. So then minus 10 plus 273.15. What will be the answer? You need to subtract it. Then you will get it. The answer. 263.15 Kelvin. Mehak, got it? Minus and minus times minus. No, minus plus minus. Minus plus equals to minus. We are doing here. Minus times plus is equal to minus. Got it. Okay. Okay. Now, interconversion of states. Now, this is a theory part, okay? We are going to see different terms which we used. Now only we know, yes, correct, Mehak. Now you are correct. We already know that when solid changes, solid can change into liquid and liquid change into gas. Now we will exactly know the terms. What is it called when we change solid into liquid? Melting, boiling, of course, we know, right? But there are more terms to it. We will see. Interconversion of states. So these are the states, solid, liquid, gas. We already aware of it. Now this diagram, now students, it is important. Questions can come from this diagram. Okay, so one by one we will see. So when we are going to start from here, okay, solid to liquid. We are going to melt it up. This is known as fusion. Okay, when solid turn into liquid, it is known as fusion or melting. Then when we have to turn liquid to gas, we will heat it up, we will provide energy, and that is known as boiling or evaporating. Liquid into vapors, liquid into steam, or liquid into gas. Now gas to solid. Gas to solid, it is written wrong here. Students, please correct this one. I'm correcting it. Oh, what happened? Huh. So gas to solid, student, anybody can clear this one because this is wrong. Anybody can state what is correct. Don't look into your note or textbook without looking at it. Gas to solid is known as deposition. You can correct this, students. Okay. No, the frosting, the snowfall is the example of gas to solid. You know what happens, students, when we go higher in the mountains, like in the Himalayas, okay, where there is temperature is very little. Now imagine if there is raining in that particular point, okay, particular location where you are in Himalayas. So what will happen now? Temperature is already low. So does the water will form in the form of rain or it will change? What do you think? It will change into snowfall, no? It will be a frost. You have seen in the Christmas movies, like in Hollywood movies, you can see there is a, even in your WhatsApp, you have this emoji, frosting emoji, the blue one, like a cross thing. So this is the result of deposition, where gas turn into solid. You can correct this diagram, okay? So we have done from solid to liquid. Now we are going back, okay? Interconverting it. So when the gas to solid is deposition, solid to gas is sublimation. Okay. We will give the examples. Okay. I will give you example here only. So solid to gas, anybody, this is very day-to-day thing which we can see, which happen in our homes as well. Solid to gas, sublimation. Directly solid changes into gas without heating it up. What is it? Naphthalene ball, correct. Yes, it will freeze and it will fall like a snow. Vapors, the gases will convert into a solid form because temperature is very low, -degrees. Okay, so sublimation, naphthalene balls is the even on camphor stick. Okay, what else? Yeah, ordinal, the room fresheners which are in solid when we will cut them up and just hung them inside our bathroom. you can see after a day, like after some days, that solid will gone, right? It changes into gases without even providing any external temperature to it. Okay. Then there is what? Solid to liquid melting. So liquid to solid freezing. Imagine the example of ice. You have the ice, like a water you have, and you are keep filling your ice tray with the liquid, and then you have to make them into solid. Then you will freeze it, right? You will put them inside the refrigerator. So liquid to solid is freezing. Now, next one, gas to liquid is condensation. Gas to liquid. Now, who will give me this example? Gas to liquid. Gas to liquid. This we have done in the primary sections, where we have condensed the gases. Where have we done, students? You remember, everybody remember water cycle? In water cycle, what happens? Cold plate kept on steam, correct, Fozan? But anybody remember about the water cycle? Is there any condensation happening in water cycle? Hydrogen, oxygen combined with water? Yes, it can be. Yes, Mehak. But try to relate the science with the day-to-day things, right? This one, Fozan has given the correct, like condensation, it happens. Height, steam, okay. Yes. One more. Water cycle one. Can anybody tell me that one? Because that is very common. We used to see that. In the water cycle, what happens, you know? Rain. Okay. Just before rain, clouds also form, no? They are condensed, like gases are being condensed to liquid. And when more liquid are being accumulated or collected, they take a form of a cloud and then the rain happens. So when the gas going up in the lower temperature, they will get condensed and they will form clouds. And cold, how does the clouds get cold? Because they are upper, no, in the sky where there is a low temperature. Okay. So this diagram, students, you have it in your textbook. You can correct it if it is written this one. Otherwise, don't make, like you already have it though, so don't make it again. But I hope you have understood the diagram. Okay. So I'm changing the slides now. Where is my eraser? Yeah. Okay. So effects of change of temperature, solid to liquid melting. These definitions are important, students. Okay, remember that solid to liquid is melting, also known as fusion. The process in which a solid substance changes into a liquid on heating is called melting or fusion. Fusion is important to know, student, because we are going to do one more terminology related to fusion. So fusion is solid to liquid, change of solid to liquid. The temperature at which a solid substance melts and changes into liquid at atmospheric pressure is called melting point of a substance. Got it, student? Whenever we provide temperature to a solid and it start melting and converting into liquid at 1 atmospheric pressure, you know, atmospheric pressure is everywhere. So in the surroundings, it will get 1 atmospheric pressure at least. Then it is called melting point of a substance. What is the melting point of a substance in Celsius scale, student? Now only we have done. What was the melting point in the Celsius scale?
100 degrees Celsius.
Melting point, students. Okay, Abhi, that is correct because you can say melting or fusion. Both are the same thing. It is written no here also, melting or fusion. Yes, Om is correct. Mehak is correct. Abhay, 0 degree Celsius. Melting point in Celsius scale, it is 0 degree Celsius, not 100. 100 is a boiling point. 100, you imagine, students, 100 degrees Celsius, when you keep on giving temperature to the water and it start boiling up. So 100 is the maximum temperature, no? 100 in the winters. Imagine you have 100 degrees Celsius in the winters. So it is winter or a summer season. Okay. So I'm asking about the melting one. So it is 0 degrees Celsius. The melting point of a solid is a measure of the force of attraction between its particles, atom, or molecules. Okay. Ice to water. The melting point of ice is 0 degrees Celsius. The melting point of iron and listen, every item or every substance or every element has different, can be like melting point can be different, but usually we take the melting point of ice as a, you can say, the relative point. To study science, we usually take solid as an example of an ice and we study about it only. But melting point of different substance or of different solids can be different. If someone is writing it, let me know. I will pause a bit and then we will move ahead. So every change in state of matter is due to temperature. Okay. Pressure is also there. But now we are learning about temperature. So we are discussing about temperature only. Okay. I'm waiting. You can do and just let me know done. Okay. So always remember, temperature is the effect, like it's the factor which affect the change in state of matter. Solid to liquid is fusion. Melting point of ice is 0 degrees Celsius. Hmm. Now next one, liquid to gas is vaporization. Now here it is a very, very important question can ask to you in the exam. What is the difference between the boiling and evaporation, students? We are very much familiar to the evaporation, right? Also boiling also. Boiling, like boiling point of an liquid is 100 degrees Celsius. Evaporation happens when liquid turn into vapors, right? But what is the difference between boiling and evaporation? Does anyone know? Are they both same, students? Boiling and evaporation are same?
No, ma'am.
Okay. Boiling is a
Ma'am, boiling,
Okay. Huh?
ma'am, boiling is a slow process.
Hmm.
Ma'am, evaporation is a slow process and boiling is a rapid process.
Correct. Correct. Evaporation happens when we, what is written? Evaporation is a bulk phenomena. Uh, is it, Mehak? Boiling is a bulk phenomena. Evaporation happens when we boil water. Okay, imagine, Abhay, there is the water on the roadside, okay? Because it's a rainy day and water is there on the road. Are you going to boil that water up in order to make it dry or to convert that liquid into vapors, or it naturally it is gone? Naturally it will evaporate, or you are going to provide some external temperature. You're going to boil that water up and then you will convert that liquid into vapor, students. Naturally, yeah. So, so this one you have written, no, evaporation happens when we boil water. No. Evaporation cannot happen like this. Like you do not need any external temperature to evaporate the liquid into vapors. Also, evaporation can only happen when the temperature is below 100 degrees Celsius. Remember that. Okay. Like in a normal environment, evaporation can happen. Vapors have more heat than boiling water. Correct, Abhay? So one more statement I have read. Just a moment. Boiling is a surface phenomena. Correct. Okay. Okay, we will see this now. I have read every statements now. So, the process in which a liquid substance changes into a gas rapidly on heating. Remember that we are providing external temperature. If we want to boil something, we need to provide an external temperature. Okay? So, it is called boiling. The temperature at which a liquid boils and changes rapidly into a gas at atmospheric pressure is called boiling point of the liquid, which we already know that is 100 degrees Celsius on the Celsius scale. Water boils at 100 degrees Celsius. Boiling point of water is 100 degrees Celsius. Boiling point of alcohol is 78 degrees Celsius. Okay. Everyone, I want you all to write about this boiling first and then I'll make you write about the evaporation. Okay, first complete this one because boiling and evaporation difference we will do if we have some time left. But today we will complete evaporation and in the next class we will do some differences between them. Okay. For now, everybody write this statement about the boiling. Boiling, yeah. So someone in the chat box, I need to correct this statement also that boiling is not like evaporation is not a bulk phenomena. Okay. Mehak has written this one. So boiling is a bulk phenomena. Evaporation can happen if you have a large surface area and water is being spilled, no? So it's evaporation like it has a property which can evaporate the water. So boiling is a bulk phenomena. You can add this line up in this statement if anybody like to add this up. This statement can also come like a reason and assertion question. Is boiling this one a bulk phenomena or evaporation is a bulk phenomena? So correct this up that boiling is a bulk phenomenon. Okay. You have done writing this boiling thing, everyone? Then we can write one statement about evaporation today. Can we? We have 2 minutes left. Okay, now everyone, I want you to write the heading evaporation. Just write one definition about evaporation. The phenomena of change of liquid into vapors. This much you already know, right? When we change the liquid into vapors, now this statement is very much important. At any temperature below its boiling point. At any temperature below its boiling point is called evaporation. So that is why we do not need any external temperature to change the liquid into vapors, but because it can happen below the boiling point. Okay. Now, in the next class, no, we are going to do the differences first among the boiling and evaporation. So today we have learned so many things. Do you have any doubt from the today's topic or anything you want to ask? Any doubt, students?
No, ma'am.
Okay, so we will meet in the next class. All right.
Excuse me, ma'am.
Halavanya, tell me.
Ma'am, if we increase surface area of water, then evaporation will happen more rapidly, no?
Correct. Because when you increase the surface area, like imagine you are going to hang your wet clothes, okay, on a rope. So you need to expand the surface area of clothes to hang them, no? You can't hang them in a very bushy, like tumbling manner, right? We need to expand their surface area and then you can hang them on the rope. So this expanding is done so that they can easily dry up. So yes, increasing the surface area will increase evaporation. We will learn the factors of evaporation in the next class also. There we will discuss the same thing. Okay? All right. Thank you, students. Now you can leave the session. Bye-bye. Take care.